All right, so the last time we were working on using the normal model to calculate percentages. So I'm going to show you some problems that are kind of backwards from that. We're going to get started using the same ACT kind of story problem. But this time, the question asks, what ACT score would give us the 25th percentile? So this time we're finding ACT scores, and we've also got this new word, percentile. Percentile means percent below. It's very important. Percent below that cutoff. So just for example, if I asked you about the 75th percentile in your mind, in the normal model, that means there's a place where there is 75% below, okay, below that spot. 10th percentile. So in your mind, we have a picture where there's some spot, and below that spot is 10%. Okay, so that's what I mean by below. So for this situation where I have the 25th percentile, give myself a little more space to work with here. I've got some spot where 25% of the data is below this spot. Okay. So in other words, here's my shaded area. I know it's 25%. Okay, cool. There's my kind of setup. I might also recognize that the middle is still 20.8. So the question is, well, what goes here? Like, what number represents that cutoff? Well, I know that there's 25% below, but I don't know what ACT score that is. I hope you're seeing why I would call these backwards problems. Usually I give you a number in this spot, and we're looking for the percent. Now we're going the other way. I have a percent. I'm looking for this mystery number. Well, fortunately, our calculator can help us out. Our calculator is really, really smart. If we give it the percentile as a decimal, it will give us the z-score for that cutoff. Pretty cool. So let's go ahead and do that on our calculator. If we go back to the distributions menu, so that's second vars, there is an option right underneath what we've been using called inverse norm. I like the INV, stands for inverse. Mathematically, inverses make me think backwards. And that's what we're doing, is a backwards problem. So I'll go ahead and select that. The only thing my calculator needs to know is the percentile. So that's 0.25. 0.25. And there we go. That's my z-score. Negative 0.67. I'll just round that to 2 decimal places. Negative 0.67. That's pretty cool. My calculator says, hey, right here is a z-score of negative 0.67. That will give you 25% below it. However, that's not actually the answer to my question. Remember, the question was what ACT score would give you the 25th percentile. I have what z-score. I need an ACT score. Well, we can actually just work backwards and figure that out. Remember, our z-score has this formula set up. So I'm just going to plug in all the pieces I know. For once, I know the z-score. That's a little different. I don't know this data point. That's this question mark. I don't know what goes there, so I'm just going to leave it as an x. Minus, this was the mean. I know the mean. It's in the story problem. And S. S stood for the standard deviation. I know that. Oh, wow. Well, now I have an equation with just one variable. This is an algebra problem. We can do this. I'll do this one real slow. But then I'm going to expect that because you have taken Algebra 2 as your prerequisite, that you'd be able to solve something like this. It might help to remember that, again, these things are in parentheses at the top. So I really don't want this divide by 4.8. So to get rid of divide by, I'm going to multiply both sides by 4.8. Sorry, that dot is supposed to be a multiply. So multiply both sides by 4.8. So I could go ahead and grab out my calculator to do that. I have 4.8 times negative 0.67. So this gives me negative 3.216 equals Now I had the 4.8 on top, 4.8 on bottom. So all that's left on this side is x minus 20.8. Simply add 20.8 to both sides. And I get 17.584 is my x value. So it looks like you'd need an ACT score of about 17.5 to give you the 25th percentile. All right, so that's how we do those problems. I'm going to go ahead and go through the beginning of one more, and I'll kind of leave you to finish up the last step. All right, so I'm going to go ahead and do this one just a little bit different. Suppose a university gives scholarships to the top 3% of students in terms of ACT scores. So what ACT score would you need to qualify for this scholarship? Meaning, what ACT score gives us the top 3%? So I'm going to start again with a picture. Big surprise there. Mean of 20.8 goes in the middle. And then I have this top. That's why I'm shading to the right. This top 3%. Remember, 3% as a decimal is 0.03. So my question is, what ACT score goes right here? What ACT score is that? I have no idea. Instead, I'm going to find a z-score and then work backwards, use some algebra. My calculator can give me this z-score if I tell it the percentile. So calculator needs percentile. Now, I know you're going to be tempted to use 0.03 because that's what's in my story problem. But remember, percentile is percent below that mark. So here's my mark. What percent is below? 97%, or 0.97. So be careful. Always give it percentile, percent below. So let's go ahead and put that in our calculator. I'll go to second vars. Option number 3 for my inverse, or my backwards, 0.97. Now, I should be thinking to myself, I am above average, so I should be getting a positive z-score. Kind of a good way for me to check that I set this problem up correctly. Woohoo, I got a positive z-score, 1.88. 1.88. So here's my z-score. I know that it's 1.88. What I don't know is what ACT score that would give me. So I'm going to go ahead and set up an equation here. Remember, I have my z-score formula, and I can plug in the pieces I know. My z-score is 1.88. I don't know my data point. I do know the mean, and I do know the standard deviation. I'm actually going to stop this problem here, and what I'm going to ask you to do is figure out, what ACT score is that? What ACT score do we need? And I'll leave that to you.